Now, my apologies, there was an error in the last video. I mistranscribed the question from page 187 of your book. I think when I wrote it down as 4 times log to the base x of 2 equals log to the base 2 of x plus 3, and I put brackets around the x plus 3. That wasn't the case, okay? The question actually doesn't have any brackets around the x plus 3. So in other words, it's 4 times log to the base x of 2 equals log to the base 2 of x plus 3. And the nice thing about that is that log to the base 2 of x, log to the base x of 2 and log to the base 2 of x, they can be treated separately. All right. Now, the one thing I want to point out here is you've got to fall back on your log rules. The first thing I notice on the left-hand side, let's take a look at the left-hand side first of all. The left-hand side has a coefficient. And one of the rules of my tables tells me that if I have a coefficient in front of a log, that coefficient may be given as a power to the number you're getting a log of. So therefore, log to the base x of 2 to the 4 equals log to the base 2 of x plus 3. And then it stares you in the face. On the left hand side, log to the base x. On the right hand side, log to the base 2. When logs have different bases, they can't be used in conjunction with one another. So the only thing left for me now is to use what we call the change of base rule. Okay, and the change of base rule tells me that in order to change a base from x to 2, as I'm going to do here, because I'm going to move away from the unknown to the known, that means I've got to form a fraction. So let's just take that over here. Log to the base x of 2 to the power of 4. Okay, I want to change log to the base x into log to the base 2. Change of base rule, prepare a fraction. On the top, just rewrite the same log with the new base. Log to the base 2 of 2 to the 4. Okay, and on the bottom in the denominator, log to the base 2 of the old base. All right, now what do I end up with? Well, the top, look at it carefully. Log has base 2 and the exponent has base 2, or the index has base 2. If the log has the base 2 and the index has the base 2, then that cancels with that and it gives you 4. So it ends up as 4 over log to the base 2 of x. So let's bring that back over here. 4 over log to the base 2 of x equals log to the base 2 of x plus 3. Snap, what is? Log to the base 2 of x equals log to the base 2 of x. So you've got the same log now on both sides, and this is where you begin to apply your knowledge of what we did in indices along with your knowledge of what we're going to do to get this thing in terms of algebra. Okay, first thing I notice, log to the base 2 of x is a difficult term to deal with. Now, when we met indices that were difficult, we involved what we call substitution. I'm going to do exactly the same thing here. I don't want to work with log to the base 2 of x just yet. So instead, I'm going to let y stand in for log to the base 2 of x. Okay, so I'm just going to make a quick switch. Take out log to the base 2 of x, let y in its place. And I'm going to rewrite this as 4 over y equals y plus 3. And now it's an awful lot easier to use. Okay, let's take it up here. Clear your fractions. Multiply every term by y. You get 4 equals y squared plus 3. Y squared plus 3 minus 4 equals 0. And you open your brackets. Y squared is y by y. Now factors of 4 with a difference of plus 3. 4 and 1. And a difference of plus 3. So plus 4 minus 1 equals 0. Y equals minus 4. Y equals 1. But they're not the solutions I'm looking for. Go back up here. Solve for x. Okay, so what I've got to remember now is that there's two cases. And I've already allowed y to stand in for log to the base 2 of x. So remember, y is equal log to the base 2 of x. And now I've got two cases. Case number 1, y is minus 4. And that's equal to log to the base 2 of x. My suggestion, go back into index form. Come out of log form, go back into index form and see if the index form is any easier to use. Now remember what we said, the base of the log is the same as the base of the index. The log is the power minus 4 and that's equal to x. And that of course is 1 over 2 to the power of 4, which is 1 over 16. So there's your first answer. Okay, now your second scenario is where y is equal to 1. So 1 equals log to the base 2 of x. And again, go into index form. The base of the log is the same as the base of the index. The log is the power, the index, and that's equal to x. And there's your second answer. X equals 2. So you've got two answers for this. X equals 1 over 16. That's your first answer. And your second answer, x is equal to 2. Now that question is also done out on page 187 of your book. It's the worked example 7.17. But when I initially took it into the main video, I transcribed it incorrectly. But that is the solution to that question there. X equals 2 and x equals 1 over 16.